All right, so welcome to day 2 or part 2 of solving exponential equations. So we're going to look at solving simple exponential equations still. We're just going to use some more properties of exponents is all. What you should already know how to do is this problem right here on the screen. So go ahead and pause the video and give that a shot and see if you can do it right now. All right. So remember that we are taking Cornell notes. You should have already been instructed to do that, and you should have your Cornell notes ready already. So let's make sure those are ready as well. All right, so let's get this one started. Let's see here. I don't have same bases, so I need to somehow write this as a 6 to the power of something. 216 is to be 6 to the power of something. And the way I'm going to do that is I'm going to take 216, and I'm going to do this upside down division. And I want my base to be 6, so I'm going to take 216 divided by 6. My calculator up here. 116 divided by 6 is 36. Divide that by 6. 36 divided by 6 is 6. So what I'm left here is 1, 2, 3 6s. So 6 to the power of 3. Because my bases are the same now, I can ignore them and just write 5n equals 3. And then divide both sides by 5. Gives me n equals 3/5. All right, so that's okay, completely okay to get answers as fractions. All right, so let's move on. Let's see here. So here's another one. Go ahead and pause the video and give this one a shot and see how this one works out. We have 3 to the power of y equals 3 to the power of 2y plus 2. So if my bases are the same, I can ignore them and write down what's left. Y equals 2y plus 2. All right, so if we have this part now, we do have variables on both sides. Remember, we need to deal with that first. So what I'm going to try to do is get my variables to one side. It does not matter which one you move. All I know is that I need to cross an equal sign. So let's just go with the keeping the variable positive. So let's subtract a y off both sides. That leaves me with 0 on this side equals 2y minus y is 1y plus 2. And then we're going to subtract 2 off both sides to get rid of the constant. So y equals a negative 2. Let's try another one. 2 to the power of 3n minus 2 equals 1024. Go ahead and pause the video and give this one a shot. All right, what you should have done is change the base of 1024 to 2 to the power of something. So I got 2 to the power of 3n minus 2. And now I need to change 1024 to the power of something. We can use the upside down division like we did earlier. I'm going to go ahead and just give that to us now. 2 to the power of 10 should be 1024, and it is. So this is 10 here. We're going to ignore the bases because now they're the same. We have 3n minus 2 equals 10. Add 2 to both sides. Leaves me with 3n equals 12. 10 plus 2 is 12. And then divide both sides by 3 to get rid of the coefficient. N equals 4. Let's try another one. 4 to the power of n equals 2 to the power of 6. Now this is new. We got different bases, but with still having those exponents up there. So make sure you guys are watching this example specifically. This is a very important example. All right, looks like 2 to the power of 6 is over here on this side. I'm going to see if I can get this 4 to have a power of 2 as well, or a base of 2, excuse me. So what I have here is 4 to the power of n, but we know that we can rewrite 4 as 2 squared. Okay, remember that 2 squared equals 4, so we're going to replace the 4 with 2 squared, and because I'm substituting there, I'm using parentheses. And with the exponent rules that I do know, If I have 2 to the power of 2 to the power of n, I can just multiply 2 and n here to get 2 to the power of 2n equals 2 to the 6th. Now my bases are the same, so 2n equals 6. Divide both sides by 2 gives me n equals 3. Let me write up another problem really quick that has to deal with this. Let's go with, doesn't really matter, 3 to the power of x equals 3 to the power of, let's see here, 3. So this one, in this case, the bases are the same, and then an x equals 3. But what if I change this base to like 9? Can we solve this one now? Well, I know, again, I'm just going to put this over here on the right-hand side. I know that 3 squared equals 9. I know this. So I'm going to replace this 9 with 3 squared, not forgetting x here, equals 3 to the power of 3. And again, with exponent rules, if I have an exponent raised to the power of another exponent here, I just multiply those. What's 2 times x? Well, that's 2x. So 3 to the power of 2x equals 3 to the power of 3. This one would be, bases are the same, so 2x equals 3. Divide both sides by 2. Gives me x equals 3 halves, or 1.5 or 1.5. All right, here's another one just like that. Why don't you guys go ahead and pause the video and give it a shot. I've got 25 to the power of n equals 5 to the power of 4. I can rewrite 25. I know I can think of a base of 5 at least. I use the upside down division. 25 divided by 5 is 5. So I can rewrite 25 as 5, 2 of these here, 5 squared to the power of n equals 5 to the power of 4. Again, I've got a multiplication rule here. A squared raised to the power of n is going to be 5 to the 2n equals 5 to the 4. My bases are the same, so 2n equals 4. Divide both sides by 2. Gives me n equals 2. All right, one more here. Go ahead and give this one a shot. This one's a little bit more difficult. So go ahead and give it a shot and see how it plays out. All right, looks like I need to change my 9 to have a base of 3. So if we do this here, 3, 9 divided by 3 is 3. So we can write 9 as 3 squared. And what I'm left with is this n minus 2 here and 3 to the power of 8. Now, 2 times n minus 2. I'm going to take this kind of over to the side here. Remember, I said that if I have 3 to the power of 2 to the power of n minus 2, we just multiply these exponents. So we're going to take 2 times n minus 2. That's this thing right here. 2 times n minus 2. You see a distributive property here. 2n minus 4. So this is going to be 3 to the power of 2n minus 4 equals 3 to the power of 8. You guys can hear my dog in the background. He says hello. Bases are the same, so I'm just going to rewrite this now as with my exponents equal to each other. 2n minus 4 equals 8. We're going to get rid of the constant by adding 4 to both sides. It leaves me with 2n equals 12. And then divide both sides by 2 to get rid of the coefficient. N equals 6. Okay. All right, here is another one. Go ahead and pause the video and give this one a shot. All right, hopefully you recognize that 4 can be rewritten as 2 squared. We still got to this power to the 4 here equals 2 to to the power of 4x minus 8. 2 times 4 is 8, so I can rewrite 2 to the power of 2 to the power of 4 as 2 to the power of 8. And bring everything else down. Now that my bases are the same, rewrite this as 8 equals 4x minus 8. Add 8 to both sides to get rid of the constant. 8 plus 8 is 16 equals 4x. Divide both sides by 4 to get rid of the coefficient. Leaves me with x equals 4. All right. Now, lastly, the last thing I want to leave you guys here with is what happens if I have an exponent that's equal to a fraction. Well, if you remember, I could rewrite a few of these. If we remember that 1, or I should say, let's just go with this route. 2 to the negative 2 can be written as 1 over 2 squared, and that simplified is 1/4. 2 to the negative 3 is really 2 over 2 to the third power, which is 1 over 8, and so on and so forth. So what I really am going to do is I'm going to focus on changing this right here to have a base of 2. And then I'm going to actually make it a negative exponent, so I have a base of 2 with a negative exponent. Let me show you what I mean by that. If I were to keep on working this up, if I wanted to just change 64 to have a base of 2, I think 64 and divide by 2 as many times as possible. 64 divided by 2 is 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. So 1, 2, 3, 4, 5, 6. So I can rewrite this now. 2 to the power of x equals 1 over 2 to the power of 6. Again, I'm just replacing 64 with 2 to the power of 6. All right, let's move forward from here. I'm going to get rid of these blue lines because they're going to kind of get in my way. All right, so I have 1 over 2 to the power of 6. Well, if I want to write that with just no fraction, then I can rewrite this as 2 to the power of x equals 2 to the power of negative 6. Again, that just comes from these properties over here. Now that my bases are the same, I can ignore the bases. So x equals a negative 6. All right, why don't you guys go ahead and pause the video and give this one a shot. All right, first thing I'm going to focus on is rewriting this to have a base of 3. So we need to take 729 and divide it by 3. Luckily, I have a nice handy-dandy calculator here. Let's see, 729 divided by 3 is 243. Divide that by 3. 243 divided by 3 is 81. Divide that by 3. Gives me 27. Divide that by 3. Should give me 9. And that divided by 3 is 3. So 1, 2, 3, 4, 5, 6. So 3 to the power of x equals 1 over 3 to the power of 1, 2, 3, 4, 5, 6. Now, this isn't quite bases the same yet. We're almost there. 3 to the power of x equals, if I want to bring this up to the numerator, then this is going to be 3 to the power of negative 6. My bases are the same, so I can ignore them for a second and just say that x equals negative 6. That's what's left over. All right, guys. That's all I've got for you. Hopefully that's helpful. If you need some help with the online activity that you guys are about to do, please ask your teacher, and they will give you most help you'll probably ever get. So if you also can work with a neighbor during this activity as well, and then go get the exit ticket and complete that by the end of class. Good luck, guys.